Alright people, so 2.3 Graphing Polynomials Part 2. The whole lesson is going to be about graphing polynomials. We're going to take what we did in Part 1 with our leading coefficient test and expand on that a little bit, and our zeros as well, remember, if they touch or cross. So only one page notes, and then we're going to do two examples. But when we want to graph polynomials, first thing we need to do is determine the end behavior using our leading coefficient test, which, remember, that we talked about if we had even or odd degree, and then also if we had a positive or negative leading coefficient. Told us if we went up or down as we went really far to the left and to the right. Okay, after we know where we're going to end, we're going to look for our x-intercepts and if they touch or cross. So remember, touch had multiplicity even, and cross has multiplicity odd. And to find our x-intercepts is when we say f of x equals 0. And then we are probably going to need to factor a lot this chapter, this section. And after that, we do our y-intercept, which means we're setting x equal to 0, or we can just say let's find f of 0. And then after we have all that information, we're also going, once we have all that information, we know our end behavior, we know these important points, we're going to plot them and then draw a smooth continuous curve to connect all them. And finally, you can use your calculator pretty easily to check. So first example, f of x equals x cubed minus 4x minus 4. So let's start with our end behavior. And we know our degree is odd. And since this is a 1 in front of here, we know that a is greater than 0. So that tells us as x approaches infinity, f of x is also going to approach infinity. And as x approaches negative infinity, f of x also approaches negative infinity. Meaning, as we get far to the right, we're going to be going up, and as we get far to the left, we're going to be going down. And next piece then we want to do is our x-intercepts, which, remember, means f of x equals 0. So I'm going to say 0 equals x cubed plus x squared minus 4x minus 4. And the trick for this one is we need to factor. So we've got 4 terms, which means we should try factor by grouping. I'm going to leave my 0 equals, and I'm going to put my first 2 terms in a group, plus I'm going to put my second 2 terms in a group. And I'm going to make sure to bring this negative in with my 4x. And now I'm going to factor this by grouping. So my first 2 pieces, I can take out an x squared, which leaves me with x plus 1. And my second 2 pieces, I can take out a negative 4, which also leaves me with x plus 1. Okay, so that then is going to leave me with the factors x plus 1 and x squared minus 4. Now here's a trick. We have x squared minus 4, so we need to recognize one more time that we can factor that. This is a difference of 2 squares. So I'm going to have x plus 2 and x minus 2, which means I'm going to have x-intercepts at negative 1, 0, negative 2, 0, and 2, 0. Okay, so that's an important piece. So we know our end behavior. We know we're going to have 3 x-intercepts. And then finally, we're going to need to do our y-intercepts, which is when we do f of 0. So if I plug in 0, I'm going to have f of 0 equals 0 cubed plus 0 squared minus 4 times 0 minus 4. And you'll notice these first 3 are all just going to cancel out. And so we have a y-intercept of 0, negative 4. Okay, so that's our first 3 steps. The next step, part D, I think we said, is going to be plotting all of these points. So I'm going to start, since I've got blue, I'm going to put my y-intercept on 0, negative 4. Okay, so I've got my y-intercept. Then I'm going to do my x-intercept. So I'm going to have one at negative 1, 0, negative 2, 0, and 2, 0. And then finally, I know, or back to the beginning, I know that as I go to the right, I'm going up. So I'm going to be up here. And as I'm to the left, I'm going to be down. Okay, the other thing, if we talk about our x-intercepts, our multiplicity is all odd. They all have just a multiplicity of 1, which means I cross at each one. So connecting these a little bit, I know that I need to come down to connect that one, and I know from here, our rightmost known point, I need to go up to connect that one. Okay, in between, I just need to follow a curve. So if I'm going to cross, I have to be up above and then come back down and go through, and I'm going to have to go through my y-intercept and then turn back up. Okay, now this isn't a guarantee of what it looks like, but it's pretty close, and this may actually come down past our y-intercept and then come back up. Either way, we have a pretty good idea, general rough curve, and if we graphed it on our calculator, we could see how accurate we were. This is what I'm looking for you to be able to do on your test. Okay, so that's one example. Looking at the next one, then you'll notice I'm going to start with my end behavior again. Okay, and I've got an even degree, and now a is less than 0. So that tells me that as x goes to positive infinity, f of x goes to negative infinity. And let's rewrite that as an actual infinity symbol. And as x goes to negative infinity, f of x is also going to go to a negative infinity. So that tells me in both the left and the right, I'm going to be pointing down. Okay, next thing is my x-intercepts, which remember is when f of x equals 0. So I'm going to say 0 equals negative x to the 4th plus 4x squared. And I'm going to factor this first. So 0 equals, I can factor out I'm going to take out a negative x squared. And that is going to leave me with x squared minus 4. And I took out the negative sign as well, so that now on the inside here I can see that I have a difference of squares. So I've got x plus 2 and x minus 2, which gives me x-intercepts 0, and this has a multiplicity of 2, which means it's going to touch, and then I'm going to have one at negative 2, 0 and 2, 0. So I should actually say my point here is at 0, 0. And then finally I'm going to plug in, I'm going to find my y-intercept by plugging in 0. So f of 0 is going to be negative 0 to the 4th plus 4 times 0 squared, which f of 0 is just going to be 0. So my y-intercept is at 0, 0. Okay, which you'll notice is the same as one of your x-intercepts. So I know that at 0, 0 I have a y and actually an x-intercept, and it's going to cross, or it's going to touch here because multiplicity is 2. And then I'm going to have a 0 at negative 2 and a 0 at positive 2. Okay, because of my end behavior, I know I'm coming down to the left and down to the right. So starting this, I know this is my leftmost known point, so I need to connect those and do the same over here. I'm going to connect those. Okay, and I know that they cross, so I'm going to be above now. And I also know that this one only touches, so it's going to have to curve something like that. Okay, and it just touches at 0, 0. It's not going to cross over. And that would be our second example. And so putting all those points together and some other knowledge we know, we can figure out our graph like this. Hey, that's it for graphing polynomials. That's how most important thing, we find our x-intercepts by factoring, by setting equal to 0 and factoring. Y-intercepts just by plugging in 0. It's always going to be whatever your constant is. And then M behavior is going to tell us what our graph should be doing to the far right and to the far left. See you next time.